Well, hi, good morning. Thanks so much for joining me here in my shop while I continue to pursue I guess restoration is the right word for this radio. So I was in here, so I'm going to be focused today on two things. One is what appears to be low output. I'm going to demonstrate this very shortly. Low output going into the audio portion of the radio, which maybe has something to do with the parts I put in yesterday. And the other is verifying, checking the alignment to make sure the radio's throughput is as much as it can be while we make judgments about whether the radio is working right or not. So that's going to be the focus today. So first thing, I'm just going to show you some of the stuff I did. I came in here last night. My intention was to simply get ready for the alignment, and I got busy doing quite a few different things. So one thing is, right away you can see all these panels are back in here. To put these panels back in, I had to move a couple of capacitors. A few of you noticed when I installed the capacitors in this area of the radio, I didn't think about where these panels were going to go. So they're in. They're bolted in from the other side. Excuse me. I also went over all the soldering. It's something I do. I never talk about it, but usually just before I finish a radio completely, I go over all the soldering that's in it and neaten it up and fix it up and that, because trying to solder properly all the way along, I don't know about that. I'd much rather come in after the fact and just go through the whole thing and clean it up. So I did that. What else did I do? I did some other stuff in here, which I can't think of right now. Where does that leave us? I think the first thing I'm going to demonstrate, or going to verify, let's put it that way, I'm not really demonstrating, verifying it to myself, is that in fact the signal coming into this network I put in yesterday is high and going out is low. And it doesn't seem quite right to me. So also in my last video I had a hum almost all the way through the video, and I apologize for that. It was just me accidentally leaving a volume level up that I shouldn't have left up. So no hum today, but I'm going to put on my headphones here. We're going to get this radio going right away. Oh, I know. I forgot. Yeah, I turned it on last night to get ready to do alignment type stuff and discovered that it doesn't work. At the end of the last video, it appeared as if the radio was limping along, but in fact it wasn't working. There was no radio received audio getting to the speaker because, as I discovered, I left one wire out. I actually didn't connect all the circuitry I put in, the output of it anyway, back into the radio. I didn't make the connection. So figured that out last night, fixed that. So now what is coming on the antenna is working its way to the speaker, but not really very good. Okay, let's warm up the radio here. Okay, there we go. Well, the radio's still operating on restricted power, around 100 volts. Okay. Oh, wow! That just dusted everything off. I can see clearly now. Let me put the headphones on again. Don't sneeze with headphones on. Okay, so I'm going to turn up the levels over here on my sound board. You can hear a bit of a hum. Okay, and this is the other level. So the hum isn't really coming out of the radio so much as it's a consequence of the connections between my audio system and the radio. So we just pretend the hum isn't there for now, and let's see what we can hear here. Absolutely nothing. Now, do I have an antenna hooked up? Yes. No. So we're on the signal generator right now. Let's leave it like that. No, well, let's not. Let's switch to an antenna briefly. Just a second here. Goodbye to the hum. That was the ground connection coming off from my signal generator. So that tells me some kind of ground loopy thing is going on. Okay, we're going to need this guy in a little bit. And my antenna connection. So So here's the outdoor antenna, just a long wire basically. Let me hook it up here. Okay. Well, I don't hear a thing. Okay, something wrong with the audio here. Perhaps. Here, the hum is gone because I took the ground off. Why do we hear nothing? Okay, well, we've taken a big step backwards from from last night. Oh, here maybe this. No. Okay, I have to start troubleshooting my own systems here. Okay, so this might hurt the ears. Everybody, careful. Okay, audio's working. Why is it hearing nothing from the radio? What did I do here that would make it stone silent at this point? Put the antenna ground on. There's absolutely nothing. Okay, let's get busy. Start troubleshooting right now. So this is my signal tracer here. I can chase down audio signals and I can chase down radio signals with this, depending upon what the settings are. Okay, so it's set for radio signals. No, I'm sorry, it's set for audio signals. Put the ground on. This may generate a hum. It's already a ground on. So play here. So this rather odd looking probe. You know, most probes are thin, slender things. Why is this a great big honker here? But there's a vacuum tube inside here, and the grid basically is protruding out here. So that's the grid to a vacuum tube, and that's to create the highest impedance they can come up with the lowest capacitance possible, so that this thing has the least effect on what it is you're touching it to. So it's very, very high impedance. Okay, so what we're going to do now is we're going to listen. Now, I don't even know if this radio is tuned to my signal generator properly. It was last time I operated it, so supposedly we should hear a tone coming out right now, a 1000 hertz tone. I don't hear anything. So I'm going to listen with this earlier in the radio, basically right on the detector. And we will see what we can hear here. Put my hand on the volume control. Now you're hearing that through microphones. So there's nothing there. So I have the feeling the radio is not tuned to the signal I'm transmitting. So let's deal with that. See if maybe that's why we haven't heard anything yet. I just haven't had it tuned. Come on, baby. Nothing. Volume up. What has happened? He says. Making sure everything is as I think it is here. Well, okay, this is not what I expected at all. What could have happened? What could I have done that I don't remember I did? What band are we on? We're not on the right band. We're not on any band here. Hang on a second. So the radio is working quite nicely. Not through my headphones though. Okay, let's get this tone on here. The best way I could do it is I want to slip here and get a shock. Come on, radio. Where are you? Oh, no, we're on the antenna now. We're on the antenna, Jim. Come on. Okay, off the antenna. Off the antenna. Watch out for that. It's 120 volts sitting right there. Yikes. I'm going to fix that later. That's an easy spot to get a shock. Boy, oh boy. Did you get that on camera? Did I get that on camera? So right here is the plug that you power your amplifier from. And so right on this wire is potentially 120 volts right to the chassis right here. So, you know, put your thumb there. Wow. Don't even demonstrate it, Jim. The chance of getting a shock there is really high. Okay, we'll put on the signal generator. I'm just going to put on the signal lead to start with, in case we can get away with that, and I won't have to listen to the. Well, we have a ground on here already, so the hum is in. Okay, let's hook up the other wire since the hum is here anyway. Okay, sounded like a little more hum came, oddly enough. So now we want to get this radio tuned to the signal generator. A little hard to see, but the signal generator number is here. 905. I hear that in the headphones. So I have this signal generator set for a very strong signal. This should come through any radio without any difficulty. See, it's not very loud here, is it? That's full volume. So now we are feeding it through all kinds of sound stuff. So what would that sound like going through the amplifier and to the speakers? I can't be absolutely sure. Maybe that's normal. But let's do a little comparison here. I'll turn that down. All you're going to hear now is my tracer. So what we're trying to find out is that really a problem? Maybe just the input signal was really, really low, which I don't think it is. I don't think it is. So we're going to listen to what comes out of. I'm trying to do this with a little bit of instrument savvy. It's very hard to see, but there's a magic eye in this right here. And I can't really get it on the camera very good. So listening to audio, this is what's coming out of the detector, and I'm going to set the volume level on the tracer over here to a certain thing. Here we go. Oh, bad connection here. Okay, so can't see my hand on the volume. So okay, give you some qualitative idea of what's going on here. Okay. Barely turn this up. So what we can do, you can't see it really, but I can see the eye, and with this adjustment I can close the eye. Okay, so set with the eye closed. Take it away, the eye opens right up, of course. Now I'm going to show you what the audio part of the radio is hearing. So this is what's coming into the network again. No, here, watch up here now. Out of the detector and into the network. out of the network and on its way to the audio amplifier. Do you hear it? To hear that, I've got to turn this volume control over here. Well, I got to turn it up. So that wasn't all that much. So here, this is what it sounds like on the output end. That's what it sounds like on the input end. There, that showed it. So, do they really want to bleed the signal down that far? Now, the thing to realize is that what you're really dealing with is signal and noise. So here's the noise and here's the signal. And so this ratio is what is going to bother you. If the noise gets higher and higher towards the signal, or the signal comes down towards the noise, you're going to get annoyed by hearing all this noise. So the radio produces a certain ratio of signal to noise here, let's say here. And then on the other end of it, it's coming out, it's not doing this. It's doing, I'm going to be able to demonstrate this. Okay, here it is going in, signal and noise, and here it is coming out way lower. This is a terrible demonstration here. But the idea is the ratio has remained the same. The ratio has remained the same. So in fact, the noise level and the signal level relative to each other hasn't changed coming out of here. So the fact that it's hard for me to hear, I have to turn volumes up, that may mean nothing. That may mean nothing. Except and then the way I'm listening to the audio here is somewhat misleading too. I'm listening to the audio at the volume control, which is past this network, before the first amplifier, or whichever tube it is. So what if I just turn up my... Now again, we got this terrible hum. Let's see if I can do this without this hum. So I have to release the grounds. Release the grounds. What do we got now? Well, that sounds a lot more like a radio, doesn't it? So probably what's happened is the signal level has dropped off because I took the ground from the signal generator away. So ultimately the amount of signal going in the radio is down. AVC is down. So the amplification of the radio is up. The amplification goes up. The noise that comes up with it. Everybody get that? I gotta get it. Yeah. So it's still a very strong signal, even if the signal generator is not grounded. It sure sounds raspy. So these could be alignment issues. So I did want to check the alignment. I think I've done enough poking around here. Pretty clear notion about the signal drop through here. What we don't know is it really important? So what am I gonna do now? So we're gonna try to do some alignment stuff. That's up, the IF alignment's up on the top of the radio. I'm gonna rotate the entire radio around here. Okay, hold on to your ears because stuff happens. This audio line here. That's interesting. No input, but we can hear something. I wonder what. So what you're hearing right now, that kind of chittery, birdy sort of sound, that's because the microphone is very close to this can. You're hearing this can here. That's what I think it is anyway. You're hearing that can. It's not coming out of the speaker. It's coming out of the can. Okay, now, let's see now. Where did their signal go? Oh yeah. Okay. hear much with this unhooked. Okay, plug him back in. There we go. Full volume. So what we'll try doing here is we're going to just touch these alignment screws a little bit and see if this is on or off. I aligned this guy before. It may still be perfectly fine. Or it may have gone off with all the work I did. So I'm going to start on this little one first. What I'm going to do is I'm going to turn it from its setting away and back and see if it goes up in strength, just with listening to it. The answer is no. In other words, I can't improve the alignment here. It's really what I expect. Okay, I'm not doing this with any kind of instrumentation really, so I'm just poking around a little bit. So it sounds to me, as I turn this, I get the impression the AVC is working. See how the noise came up as I tune it out? The AVC should be reflected on the Magic Eye tube, but I pulled it out of its socket, put it away. So we'll put a meter on it. But there's no problem with these. These are tuned. These are tuned fine. So all that work I did had no effect on these, and I'm not surprised. The capacitor and the coil combination that's working here is inside the can, and everything outside the can, I'm not sure it can influence the resonance inside the can. So that's fine. So now it could be the front end alignment, which I haven't touched. It could be way out. There's a really good chance of that. So I don't think there's any more for me to do up on the top here, so we're going to rotate it back. Now, how can I quickly determine if there's a problem with the radio front end? Well, I think I've already done that, in fact, come to think of it. Since I was able to hear a wonderful signal, it sounded great at the start of this, but by the time we get to the end, it's just so weak. It doesn't make sense. Now I've verified all this last night, but that doesn't mean I got it right. There could be something wrong in there. And another very distinct possibility is one of the key resistors here is R46, and on this diagram I can find 3 of them. I can find 3 resistors where the label looks like it could be 46. Maybe it's 45, maybe it's 48, I can't tell for sure. So there's a chance I've got R46 wrong down here, which I don't think I do. I was thinking though. So R43 is a 56,000. I just would have thought the next resistor would be 10 times bigger. 500,000, but instead it's 10K. If it really is R46. So a smaller resistor, I know you probably can't see this well, but the signal is coming off of the resistor I'm talking about. So if this resistor is way small, the signal will be way small because it's being divided by these 2 resistors. If you want more oomph coming out here, you need a much bigger resistor here. I'm going to take a closer look at that I'm going to take a closer look at the schematic. Maybe I just got the wrong size resistor there. Let's take a look. Okay, let's take a look at the schematic. First, we'll take a look at 46 as it appears. The one I think is 46 here. So you see it right here on the far left side. This is the resistor we're talking about. When I look at that number, to me, I see 46. There's 47. Here, 40. There's 40, 41. That looks like 46. Now if we look at another part of the same schematic up here, if I can find it, there is another R that could say 46. Where did it go? There it is right there. That could be 46. So if this is 46, you know, I could find this. This is original. I could find this and see what size that resistor is. You know, that's a good idea. Let's do that. I like that idea. Thank you very much. First 6K7, in the sense of the order they come through the radio. First 6K7 off of pin 5. Okay, let's check it out. Okay. I don't want to forget this radio is on. So 46 off the first 6K7. This one, pin 5, 1, 2, 3, 4, 5. A resistor off of that pin. So there's the resistor. Oh, jeez. Yeah, okay. I don't know how well this is going to work, but when you look at that resistor, a little out of focus here, I can see a brown, I can see an orange, I can't see anything else. So we can guess that that's brown, black, orange. Poorly as it's visible here. Brown, black, orange. That's 10K. Guess what? That's what 46 is. Okay, so I have a 10K here that maybe this isn't 46. If it's not 46, I think it has to be 48. 48. So I don't think I saw a 48 anywhere else. Okay, so if it's 48, it would be 220,000. 220,000. I'm saying it should be like 10 times the 56K roughly. So you get a divider ratio of 1 to 10, and you get like 90% of the volume across the resistor we're taking the output from. Whereas right now we're getting a tiny portion. We're getting 20% of the available signal showing up on that resistor and then going on into the radio. So I think I got the wrong size resistor there. I think maybe what I'm going to do is I'm going to peek at a few other schematics here and just see how, like, this is a very common circuit through coming out of a detector, a couple of resistors, a few capacitors to snuff out the RF. It's really very, very common. Let me just look and see what other radio ratios show. Okay, so we're going to take a quick look at a bunch of radio schematics here and just examine how the detector is done, and to help kind of get a grip on what they're doing in the radio I'm working on. So if you're going to do this, the first thing to do is spot the detector tube. Either it says it detector, or you can spot the little plates. There are little plates in there. A little hard to see on this schematic. It's always associated with the secondary of the last IF, because that's what you're going to rectify through these little plates. And the output is always found down in this area of the radio schematic. So here we go over here. Look at this one. Right out of the IF transformer, the last IF transformer, right into the volume control, right to ground. This just is as simple as can be. So all they're doing is just taking the output of this, putting it across this resistor, and how much is this? 1 megohm resistor here. You don't want to draw much current from this circuit. And that's it. No fancy network going on. This line continues down here to this resistor. Look at the size of that, 3.3 megohms. So this is the AVC line. So you've got the audio going this way, and there should be a there it is, a capacitor stopping any DC from continuing this way, and the DC comes down here and is shot back onto the grids. Okay, so a little longer explanation for that one. Simple as it gets, right out of the can, right into the volume controller, right to the chassis. Simple as it gets. Okay, in no particular order from now on. That first one was the simple one. We'll just look at all these different radios here and how they deal with this. Tube with the plates, there it is. Last coil. Output, okay, a little funny thing going on here, but let's follow this one. Output through a resistor down to volume control, the bottom of which, well, who knows where this is going in this radio. Let's just pretend that's ground, but that's probably a little pretentious, but let's pretend it. So in this case, it's coming out through two resistors. Now, what is the ratio of these resistors? So this one is, I think it's 47,000. And this one is 1 megohm. So 50 versus 1 megohm, what's that? That's a ratio of 20, isn't it? 20 to 1? 20 to 1? So the bulk of the output signal coming out of here is going to end up across here. Volume control to pick it off and send it. That's how they do that one. One resistor ahead of the volume control. So I'll look at this one. Okay, so here it is, detector. In this case, it's coming out here, down. I think this is probably the AVC line going across here. No, it's not. This radio is all, these tubes are upside down. These are upside down. Coming out of here, I may not be able to analyze this. I tried to pick ones I could analyze right away. Well, I'm getting stuck because it's crossing the B minus line here. So I don't know what's going on here, but let's just look at the resistors quickly. So 2 meg volume control. It appears to be, if you just follow a line, it appears to be straight off the detector plates up here. Control. Yeah, okay, straight off. A straight off one. A straight off one. Let's try this one. Coming down here, going to the coil, coming out the bottom. So here we are. Straight into the volume control. Again, no resistor up here, and this is probably the takeoff for the AVC going up here. Yep, right up to the grid. These tubes are upside down again, for crying out loud. So again, out of the detector, straight into the volume control. And the volume control is how big? R6, pot and switch 500,000. So again, it's fairly large. You don't want to draw current through the circuit. There's no advantage to drawing any current. So here we are, second transformer. There's the plate. There's the capacitor to quiet the radio. It's the same size as the one in this radio, 100 picofarads. Down here, straight into the volume control again. A great big resistor over here. And how much is the volume control? 500,000. So it looks like sometimes they put a resistor in here and sometimes they don't. Okay, this guy. Out of the plates, 200 picofarad this time, quieting here. 50K. That M really means 1,000. It means a meal. It's French for 1,000. 50. Yeah, don't be fooled by the M here in some radios. They'll write meg if they want it to be megohms on a radio like this. So it's 50K. And what's the volume? 500K. So I think this is a great model right here to look at, just a wee bit longer. So we're coming out of, this is a classic, I believe. Coming out, coming down, capacitor trying to kill the RF, because who needs it now? What little might be left. Come down, 50,000, 500,000. 1 to 10 ratio. So something like 90% or so of the signal level coming out of this arrangement is going to show up across here, almost all of it, because this is 10 times the size of that. In the radio we're working on, it's the other way around. This is 10 times the size of, well, 5 times. This is 56K, similar to this, but the next resistor you run across is 10, and maybe it should be 220K. That's where I'm thinking. And then again, you have this big isolation resistor here, isolating away the grids out this way, and then a capacitor here to slow the DC variation that'll happen on this line if the signal is varying coming through here. The amount of DC, signal strength is varying, not the program material, but the actual RF signal strength. like a fading signal on shortwave. Then the DC developed here goes up and down too. And the up and down is sometimes undesirable to have it go up and down really quickly. So they put a capacitor here to slow the up and down out here on this side of the big resistor. So this might be going up and down quite a bit, and over here it'd be going up and down just a little bit. That's kind of the idea of that. So this is a great radio to look at. So this DC coming down here, they've got to block it somewhere so it doesn't get all the way back up to this grid, and they block it right there with a small capacitor over here. Good. I think oh, I got another one. I got one more to go. I got more than one more to go. Got another one. Let's look at this one. So this one comes out. Wait a minute, don't be fooled. It's the same radio. Yeah, same radio. Same schematic. Whoops. So our last one to take a look at. Where's that detector tube? Okay, so last I have, there it is. There's the plate drawn right in there. Back down. So now we come down. We hit a 22K resistor. We then carry on to a large 1 meg volume control, and then it goes on to a 470, a very small one here. So I think these two here, I'm not sure what they're doing. What are these doing? I don't know. But look at the size of that. 1 meg versus 22K. So again, you've got the 1 to 10 sort of ratio, the small and big ratio here, which I think is wrong. So what's happening here is I'm convincing myself that what I thought was true is true, that the ratio is wrong on those. This is the wrong size. This is the wrong resistor. So, lucky me, eh? Okay, so that's the wrong resistor. I think I'm going to switch this with one 10 times the size, at 220K, on the assumption that it's R48. Wasn't that right? Sorry about the big bang. R48, 220K. Good. I'll put it in. We'll see what happens. Okay, I think we're ready to go here. We're gonna give this guy a go. Let me just turn off that soldering iron. So I have the new resistor installed here. I think we're okay. Here we go. I'm watching the dim bulbs because I really can't imagine that would cause any serious trouble in the radio. Dim bulbs normal. All is normal. Where in the world is normal these days? What has happened to normal? So, okay, let me turn up the volume here on the sound panel. Oh, I hear something. Okay, that's a good start. Where's the volume here? Well, we're better off, eh? We got more. Still seems pretty low. But remember what I told you about signal to noise? I mean, I can change this. No, I can't. I was going to say I can change it, but I can't. Let's compare now the signal level from the start to the finish of the using the tracer. Okay, let me just bring it up here. We're going to hook a ground on here. Maybe make a hum. Nope. Yep. Make a bit of a hum. Just putting the ground wire on for the signal tracer. Let me just turn all the volumes down on the microphones. Just hear what this is here. Well, that doesn't make sense. It's the other way around. Turn the volume down on the radio so all we hear is what's in the microphones, right? Okay. Going out. We'll start with the going out. Here's the going out. Okay, and here's the coming in. Yeah, it's still wildly different, isn't it? still. So what happened? There's a fairly large capacitor across this resistor. Kind of, that could be wrong too. Okay, going out, coming in. Wow. So what about that big fat capacitor I've got in here, which is right across the resistor that's developing the audio? It looks like a 0.1. Does that make sense? That would be this one here, I believe, 34. This one here. So C34. Oh! Okay, so I'm just gonna, okay, so I'm gonna just verify that I haven't done something stupid in here. There's always that remote chance I've done something stupid here. Okay, and see what went wrong here. So here's one of my earlier sketches. And there's R46 at 10K, which of course I just changed to 220K. And there is C, well, it's supposed to be C34. But when I looked at the chart here of components, I accidentally, instead of looking at 34, I looked at 38, which is a 0.1, and I wrote 0.1. And that's why there's a 0.1 in this radio, when it should be 34. Let me just double check again. Another 100 picofarad. So another part to change. How embarrassing is this? You know, I know myself. I've been around with me for a long time. You know how easy it is for me to make mistakes like this. So I'm always on guard for my own tomfoolery. So this big, here we are. We're on. That big capacitor's got to go now. Oh man. Oh man. But that should fix it, because what's happening right now is the capacitor, just in case it hasn't come clear, we're trying to develop the signal across this resistor here, 46. And what's happening is the capacitor here is just eating it all and sending it to ground. So this is way too big, way too big. We'll put a smaller one in here, and we'll be off to the races, I'm pretty sure. Okay, that's what I'm going to do then. Let's change that. Okay, ready or not, we're going to give it a try. Turn the volume down in anticipation. Anticipation. Headphones on. And remember, the volume was just screaming out of this thing, and that's when the output of the detector was sent straight to the volume control, like it is in so many radios that we looked at. Now it's going through this rather complicated network here of resistors and capacitors, probably to alter the tonal quality of the sound a little bit. That's probably what's going on there. Are we ready? Radio on. Volume up a little bit here. That's our sort of video volume, we can call it. Radio volume is, well, it's right down now. What am I hearing? I'm hearing something. Let's turn it up. Oh, look at that. It's all there now. 2 thumbs up. Let's just double check with the signal tracer here. How different is it? This is the output going into the audio amplifier. Sounds like that. And this is the output of the detector. Oh, bingo. Sounds the same. Now we're cooking. So now the radio is delivering everything it's got at the detector over to the volume control. It's not burning it up or dumping it with capacitors here. Excellent. Excellent. So where does that leave us? That leaves us time to try listening to this radio, I think. Okay, so we're gonna go, well, let's not quite do that just yet. Let's just, because we're set up to do this, let's just check the sensitivity of this radio as it stands. So that's just doing it by ear. Tune the radio first. That's a lovely AVC sound there. That thump, thump, thump. Okay, now the signal strength is actually fairly high, and do I have the ground connected? I can't remember now. Have a look. Okay, ground not connected. So I have to connect the ground on the signal generator output, so it's in the same state that I usually in making this comparison. So let me put it on over here. There. So the input impedance to the signal generator is very low, 50 ohms, and it's now across the antenna. So in a sense, I've shorted out the antenna. That's kind of why the radio went a little bit quiet there. All that's left now is the signal. So volume not very high. I can hear it. So this is a very good sign. A very low signal strength. Okay, so this radio has typical radio sensitivity now. It's working like any decent radio would. It's responding to a fairly low signal. That's excellent. That's really excellent. Super excellent. We really got somewhere this time. And for the first time, the radio is really performing well, I think. So check the IF alignment. What's left now is to check and adjust all these adjustments. I'm not inclined to twiddle any of this just to see what happens. I can't stand it though. Let's do that. So what I'm checking now is just to see if there's anything good there. So I think it's this set of coils. I think this is the oscillator. Yeah. So we're going to stay away from the oscillator. Fiddle with these two. All I'm going to do again is turn them a little bit this way and that way and see if it gets stronger. And then I'm going to put it back to where it is. Well, this is wide open. Oh, see, it's right on the peak. Well, I would say right on the peak. This one here. There was a little bit there. It was sitting over here, so I'm going to leave it where it was until we do this with instruments and do it properly. Okay, so nothing too dramatic happening there. This affects the tuning of the radio. It doesn't affect the sound, the output quality. So no use fiddling with those. Okay. Hey, why don't we, since we know the AM band, we're listening to it, why don't we at least check some of the other bands? Great idea. Okay, so the next band up. Did I go right by it? There it is. Volume up. And we're not on an antenna. We're not on an antenna. I don't know what frequency we're tuned to or anything. It'll take quite a while to hunt it down with a signal generator. And I don't know for sure it's there to even be heard. The bands, you know, if I probably had the glass in my hand, that would help. Or is it written right on here somewhere what the bands are? Frequency range. Okay, so we can guess the first shortwave band from the AM band is probably going to start at probably 5 or 6 megahertz and go up to probably, I don't know, 11. I don't know. I'm just guessing here. That's really not going to work. Let's do this. I'll put an antenna on it. We'll tune around and see what it sounds like. Let's do that. That's probably a better approach. Signal generator off. There's my antenna cord here. Make sure we're listening to this. Oh yeah, we are. Pretty darn quiet. Do we hear this? Oh yeah. There we go. Okay, hey, excellent. That certainly sounds like a radio. Oh yeah. Oh yeah. Okay. One more band to check. Well, we'd never hear anything today at this time of day on this band. We go up one more. quiet up here. And there's even more adjustments way up there I forgot about. You can't see them normally. Ooh, yeah. Well, so this band is pretty darn quiet. Total silence. It's lighting up the most left one. You know, this I think AM, shortwave, high shortwave. I got it all backwards here. So it sounds like the two extreme shortwave bands, that's the long wave, which is just above AM, and the high frequencies that we're trying now don't seem to exist. Okay, well, that's a little look ahead. We will work away at that and hopefully solve it. So where are we at here? A recap. Radio appears to be working. Audio is not really a problem. Certainly with the AM apparently receiving, there's no reason to doubt quite a few things like the IF string and stuff like that. It's all been proven out. So what hasn't been done is a front end alignment, except for you saw me twiddle just a wee bit here. Maybe going through the alignment process properly now. We'll try to bring the AM band up to full power and see if we can't bring the others to life. That's it for today, though. Great. So yeah, I made mistakes, but I saw my mistakes. Great. See you in the next video.